Good afternoon, it's Mr. Pack here again. It's Chemistry B, Unit 5, Equations in Stoichiometry. Today we're going to talk about moles and mass calculations, mole ratios, balanced equations, and things like that. So let's get started. First of all, we need to understand that a balanced equation tells us lots of information. Now remember, a balanced equation will tell you exactly how much and what substances are required to complete a reaction. We have the products, and we need to know how much of the reactants we need to have to make these said products. A skeleton equation tells you just what there are, what the ingredients are, so to speak. Whereas the balanced equation gives you the recipe. That includes the amount and the substances. Okay? One of the things that a balanced equation can tell us is it can give us a mole ratios. Okay? A mole ratio is a conversion factor derived from the coefficients of a balanced chemical equation interpreted in terms of moles. We use mole ratios to convert between moles of a reactant and moles of a product, between moles of reactants, or between moles of products. Let's take a look. We're going to use this formula in our sample problem a little bit later on. Okay? But what ratios can we get from this formula, from this equation? N2 plus 3H2 produces 2NH3. What ratios can we get? Well, there are three ratios that we can get from this formula. We know that 1 mole is a ratio with 3 moles of H2. 1 mole, 3 moles of H2. We know there are 2 moles of NH3 for every 1 mole of N2. And we know 3 moles of H2 for every 2 moles of NH3. Alright, so those 3 ratios we can get. 1 mole of N2 for every 3 moles of H2, 2 moles of NH3 for 1 mole of N2, and 3 moles of H2 for 2 moles of NH3. Okay? Now we can calculate, we can do mole-to-mole calculations. Alright? Here's the formula. Alright? Given is what's in the problem. The mole ratio is what we would use to solve the problem, and this is what we do when we calculate it. So let's take a look. W is the unknown quantity. G is the given quantity. And values A and B are the coefficients from the balanced equation. Now this will look a little bit more easy to determine and understand if we do a sample problem. So let's do that right now. We'll look at page 360, sample problem 12.2, and this will also include that ratio, the N2 plus 3H2 produces NH3 formula that we were talking about earlier. So let's get started calculating this. Okay, so our sample problem is how many moles of ammonia are produced when 0.60 moles of nitrogen reacts with oxygen? Now remember, we're going to use the formula that we used on the previous page. So the formula is N2 plus 3H2 produces 2NH3. Okay? So, step number 1, it says how many moles of ammonia are produced when 0.60 moles of nitrogen reacts with hydrogen? Okay? What do we know? We know that there is, 0.60 moles of N2. Okay? The conversion is moles of N2 to moles over NH3. So, we have to go with what is given. And what is given is 0.60 moles times, and then here is where we use the conversion factor. Okay? And the deal is you take what's given here. So what is given here was mole of what? N2. So what's our conversion factor? How many moles of N2 do we have here? Well, you know that if it's not shown, it's 1. So it's 1 N2. All right. And then what are we trying to find out? We're trying to find out NH3. Okay? We're trying to find out NH3. How many NH3s do we have? We have 2. So the mole ratio is 2 NH3. Okay? So you multiply those out. Of course, we know that moles NO2 will cancel out. So it becomes 0.60 times 2 equals 1.2. Okay? And that is how we get that. So you take what is given, what you know, and you put that right here, and you put that right here. Now what you're trying to solve for, goes here and here. And then you just plug in the ratio. All right, let's continue. I'm going to use this screen up right here to do another one of these problems. I'm going to do sample problem 11 on page 12.2. The formula is 4 aluminum plus 3 oxygen produces 2 aluminum, 3. Sorry, that's a 3. All right. Now, part A asks you to come up with the 6 mole ratios that you can get from that. I'm not going to do that. Remember our formula though. I'm going to write this over here. And the best way to remember this is you go given times given unknown equals unknown. So there's the unknown over there. Now, why do I put it like that? You'll see here in a second. It says, how many moles of aluminum are needed to form 3.7 moles of Al2O3? So, what do we know? We know Al2O3, and that was 3.7. And it's asking how much aluminum was needed. So this is the known, this is the unknown. Okay? So it's known, known, or given, given, unknown, unknown. Okay? So it becomes 3.7 Al2O3 times equals, all right, so that's given right here. So what's the ratio of Al2O3? It is 2. So it's 2 Al2O3. Unknown, aluminum. And that will tell us how much aluminum we need. What is our ratio here? It's 4. 4 aluminums. Now remember, this part here and this part here is just taken from the equation. It's the coefficient from the equation. Of course, this is 4 over 2, which is basically can be reduced to 2 times 1. This will cancel out. This will cancel out. 2 over 1. So now it's 3.7 times 2. 3.7 times 2. And for that, we should get a mole ratio. We should get 7.4 grams, or excuse me, 7.4 moles of aluminum. All right, next, we are going to calculate the mass of a product. All right, sample problem 12.3 is what we're going to do next after we talk about this. Okay, the steps in solving a mass-to-mass problem. Number 1, change the mass of given to moles of given by using the molar mass of the given. Mass given times 1m over molar mass equals moles given. Number 2, change the moles of given to moles of the unknown by using the mole ratio, that's not ration, mole ratio from the balanced equation. Mole given times, those are our coefficients again, so given, given, unknown, unknown. And then change the moles of the unknown to grams of the unknown by using the molar mass of W, which is the given. Okay? All right? So those are the steps, and we're going to do that right now. Okay, our sample problem is calculate the number of grams of NH3 produced by the reaction of 5.4 grams of hydrogen with an excess of nitrogen. The balanced equation is N2 plus 3H2 produces 2NH3. Okay, we are going to use hydrogen in our calculations here because it tells us in the problem that nitrogen is our excess. So that is what's going to run out. Excuse me, that is what's going to be left over because hydrogen runs out. Since hydrogen is a limiting reagent, we'll start with that. Okay, so I already have up here what we know. We know that the mass of hydrogen is 5.4 grams for that hydrogen 2. Okay, we know that 3 moles of hydrogen 2 is equal to 2 moles of NH3. That's our mole ratio. We know that 1 mole of H2 is equal to 7 grams of H2, and that's the molar mass. Okay. Excuse me, that's not correct. 1 mole of H2, 2 grams of H2, okay, because that's the molar mass, 1 gram for each, so that's 2, all right, and 1 mole of NH3 is 17 grams, that's the molar mass of NH3. Nitrogen plus H3 equals 17 grams. So that's where we got to calculate the molar mass here, all right. What is unknown is the mass of ammonia, NH3, okay? Now the book says to do all of this all in one line. I don't like to do that. I like to use the steps that I outlined before. Step number 1, change the mass of a given to moles of given by using the molar mass of the given. So our equation that is set up is 5.40 grams times 1 mole over 1 mole of H2 over 2.0 of H2, that's the molar mass, will equal 2.7 moles of H2. Alright, so step number 1, change the mass of the given to the moles of the given by using the molar mass of the given. Step 2, change the moles of given to moles of unknown by using the mole ratio from the balanced equation. So we take what we just did, which is 2.7 moles of H2. That's the given. So what's our H2? Our H2 is a 3. We're trying to get to NH3, so it's 2. And that is going to give us moles of NH3. Moles of NH3. Okay? And when we do that calculation of 2.7 times 2 over 3, we get 1.8. Next step is to take moles and convert it into mass. So we take moles of the unknown, which is 1.8 grams of NH3, and we multiply that by molar mass of the unknown, which was 17 grams, of NH3 equals, and it's going to come out to about 30.6 grams of NH3. And that is how we do that.